Welcome back. In this lecture, we will be looking at the address resolution with respect to IPv4 and IPv6. This is the module 9 of the Cisco NetAcad Introduction to Networks lecture series. If you would like to watch the previous lectures, I will leave a link in the description with the lecture playlist so that you can go ahead and watch them. In this lecture, we will explain how ARP and ND enable communication on a network. We will look at the MAC and IP, ARP with respect to the IPv4, for example, and the neighbor discovery or ND with respect to IPv6. MAC and IP. There are two primary addresses assigned to a device on an Ethernet LAN. The layer 2 physical address, which is the MAC address, and the layer 3 logical address, which is the IP address. The layer 2 MAC address used for network interface card to network interface card communications on the same Ethernet network, while the layer 3 logical address, which is the IP address, is used to send packet from the source device to a destination device. The layer 2 addresses are used to deliver frames from one network to another network. That's a very important concept that you learned on our previous modules. And if the destination IP address is on the same network, the destination MAC address will be that of the destination device. So this particular slide basically showing that what we already learned, and it's just quickly describing what it is. It's just a quick summary of what we have covered in our previous modules. Again, if you would like to watch the previous module lectures, you can go ahead and check my YouTube channel and you'll get to those lectures and you can watch them. So you should already have an idea about the difference between a MAC address and an IP address. So remember, MAC addresses are used for communication between network to interface card to network interface card within the same Ethernet network, while the IP addresses can be used to communicate across multiple networks. Destination on remote network. When the destination IP address is on a remote network, the destination MAC address is that of the default gateway. ARP is used by IPv4 to associate the IPv4 address of the device with the MAC address of the device network interface card, while the ICMP version 6 or ICMP-v6 is used by the IPv6 to associate the IPv6 address of the device with the MAC address of the device network interface card. So remember, in IPv4, the process is the ARP that is used for the association of MAC address to the network interface card, while in IPv6, the ICMP-v6 is the process that it will be used to associate the MAC address to the network interface card. If you have access to the NetAcad, please go ahead and do your packet tracer lab associated with this particular module. And I will be posting these packet tracer labs on my YouTube channel in the future. So it's not going to be part of this lecture video, so I'm just going to skip through this slide. But if you have access to the Cisco NetAcad, you should stop right now and then just go ahead and do this packet tracer lab, which is titled Identify MAC and IP Addresses. ARP. A device uses ARP to determine the destination MAC address of a local device when it is known its IPv4 address. ARP provides two basic functions: resolving IPv4 addresses to a MAC address and maintaining an ARP table of a IPv4 to MAC address by simply mapping them. So again, ARP provides two basic functions: resolving IPv4 addresses to a MAC address and maintaining an ARP table of IPv4 to MAC address in the device. To send a frame, a device will search its ARP table for a destination IPv4 address and a corresponding MAC address. So just like a like a CAM table, we will have an ARP table that will have the destination IPv4 address and the MAC address associated with that IPv4 address, or these specific IPv4 addresses and the MAC addresses associated with those specific devices. If the packet's destination IPv4 address is on the same network, the device will search the ARP table for the destination IPv4 address. If the destination IPv4 address is on a different network, the device will search the ARP table for the IPv4 address of the default gateway. This is very important concept that you should learn. If the destination IPv4 address is found on the ARP table and it is on the same network, the device will search the ARP table for the destination IPv4 address. But if the destination IPv4 address is on a different network, the device will search the ARP table for the IPv4 address of the default gateway. So that's an important concept that you understand. And if the device locates the IPv4 address, its corresponding MAC address is used as the destination MAC address in the frame. And if there is no ARP table entry found, then the device sends an ARP request so that it can update that ARP MAC address, IP address, MAC address relationship. So remember that if there is no ARP table entry found, then the device sends an ARP request, and that request is used to update the ARP table so they can associate that IP address with the device MAC address. There's a video that explains this much better using a demonstration, and this video is available to you on your Cisco NetAcad website. If you don't have access to Cisco NetAcad, I will post a link in the description for a copy of that video. It's called the ARP request. You should go ahead and check it out, and that will explain this much better. So yeah, that's what this slide about. And the next slide, there is another video about ARP operation. It's called ARP operation ARP reply. And again, if you have access to Cisco NetAcad, you can go ahead and watch there, or I will leave a link below in the description, and you should watch that video as well. And even in the next slide, we're gonna have the ARP role in remote communications video. It's again a demo created by Cisco NetAcad people, and I have a copy of that available on my YouTube channel. I will leave a link below. If you do not have access to your NetAcad account, NetAcad course material, you'll be able to watch that. And I will leave also a card on our on this video. It's on the top right hand corner. You can click on the cards and you will see the list of it. So all of these three videos, it should appear on the top right hand corner cards of this YouTube video, and you should be able to click on those and watch those. Removing entries from an ARP table. Entries in the ARP table are not permanent and are removed when an ARP table cache timer expires after a specific period of time. So remember how the ARP table get updated with the specific IP address and associated MAC address, and it use that ARP request to get that information so that the table get updated. Well, when there is a timer so that those entries get cleared once it's not been used for a while. So the destination of the ARP cache timer differs depending on the operating system. So Cisco devices may have a certain ARP table configuration compared to a Windows device and some other device, etc., etc. ARP table entries can also be removed manually by the administrator by sending a command to the router or the switch or the end device. What you need to remember is the ARP entries are not permanent and are removed from the cache after a specified period of time, or sometimes when the device gets rebooted. ARP tables on networking devices. So on Cisco networking devices, especially on routers, you can type the command show IP ARP, so show IP ARP command, and that will display the ARP table for that Cisco device. And this is an example of a Cisco router that displaying that information with the show IP ARP command. On Windows computers such as Windows 10 and Windows 11 PCs, you can open the command prompt, and then on command prompt you can type ARP-A, so ARP space -A, and that will display your ARP information, the ARP table on your Windows PC, and then you can use that for your network administration purposes. ARP issues. ARP broadcasting and ARP spoofing. ARP requests are received and processed by every device on the local network. Excessive ARP broadcast can cause some reduction in performance. Such as it could actually create things like network congestion, for example. ARP replies can be spoofed by a threat actor to perform an ARP poisoning attack. Enterprise level switches include mitigation techniques to protect ARP attacks. So I will not go into detail and depth of ARP attacks and how excessive ARP broadcast could create network congestion in this lecture. I will post a separate video explaining different network attacks and how you can mitigate them. But for this course, what you need to remember for this module is that there are vulnerabilities with ARP. They include ARP broadcast, which could create network congestion, and the other one would be the ARP spoofing by a threat actor that could cause a ARP poisoning attack. And in terms of detail on how they work, I will go over that in a different video. For now, just remember that ARP broadcasting and ARP spoofing is have some vulnerability issues in our network systems. Again, if you have access to your Cisco NetAcad, there is a packet tracer lab that you should be doing. I would pause this video, go ahead and do that lab, and then come back and watch the rest. And again, I will make sure to post those Cisco NetAcad labs on my YouTube channel later this week. IPv6 and neighbor discovery. Again, there is a video made by Cisco NetAcad called IPv6 Neighbor Discovery. That video will explain the process of how IPv6 perform address resolution using ICMPv6 neighbor solicitation and neighbor advertisement messages. And I will leave a link in the description of this video in case you do not have access to Cisco NetAcad material. And you can also click on the cards at the top right hand corner where you can click on that video and watch it. IPv6 neighbor discovery messages. The IPv6 neighbor discovery or ND protocols provide address resolution, router discovery, and redirection services. ICMPv6 neighbor solicitation NS and neighbor advertisement NA messages are used for device-to-device messaging such as address resolution. ICMPv6 router solicitation RS and router advertisement RA messages are used for messaging between devices and routers for router discovery. ICMPv6 direct messages used by routers for better next hop selection. Each one of these items I will go in detail later, but for now, for this course, this particular modules, what you need to remember is that the neighbor discovery ND protocol provide these items like address resolution, router discovery, and redirection. And the NS, NA, RS, RA, why we use it, and what these items are responsible for in the IPv6 neighbor discovery messages. IPv6 neighbor discovery address resolution. IPv6 devices uses neighbor discovery to resolve the MAC address of a known IPv6 address. ICMP version 6 neighbor solicitation messages are sent using special Ethernet and IPv6 multicast addresses. So that's how it actually communicates between IPv6 addresses. So we have a ICMPv6 neighbor solicitation message. It would be something like just like saying, hey, whoever has this particular IPv6 address, please send me your MAC address. So it's like a ARP message, but for IPv6. And then when that message was received by this particular IP address, in this case in the PC2, it's going to reply back saying, hi, I am that IP address and my MAC address is so on and so forth. And then that information get updated when the message being received back from that advertisement message. So we have a ICMPv6 solicitation message saying, hey, I need that who has this IP address, please give me that MAC address, belong to that IP address. And then the device that has that IP address gonna give the ICMPv6 neighbor advertisement message, and that will give that connect that IP address to that MAC address. So that's how it works. Again, this is just briefly going over how IPv6 work, and I will go into depth of exactly how IPv6 neighbor solicitation and neighbor discovery and all of these things work on a later video. But just for now, just remember this is how IPv6 differ from IPv4 ARP messages. There is a packet tracer lab activity on your Cisco NetAcad, and if you have an access to your Cisco labs, go ahead, you should be doing that right now. Again, I will post those labs on my YouTube channel later, sometime this week or upcoming weeks. And this is the end of this lecture, and I will quickly go over what we learned in this lecture. We learned that the layer 2 physical addresses such as Ethernet MAC addresses are used to deliver the data link frame with the encapsulated IP packet from one network card to the next network card. But however, these physical 2 addresses are being used to communicate between network card to network card on the same network. If the destination IP is on the same network, the destination MAC address will be that of the destination device. When the destination IP address, whether it's IPv4 or IPv6, it doesn't really matter, is on a remote network, the destination MAC address will be the address of the host default gateway. For example, in your house, your default gateway going to be your router's interface. An IPv4 device uses ARP to determine the destination MAC address of a local device when it knows the IPv4 address. ARP provides 2 basic functions. They are resolving IPv4 addresses to a MAC address and maintaining a table of IPv4 to MAC address mapping, which is we call the ARP table. After the ARP reply is received, the device will add the IPv4 address and the corresponding MAC address to its ARP table, hence updating that ARP table. For each device, an ARP cache timer removes ARP entries that have not been used for a specific period of time. And that timer changes based on the device that you are using, such as Cisco devices versus D-Link devices versus your Windows device. So it's a random timer. IPv6 does not use ARP. Instead, it uses something called neighbor discovery protocol to resolve MAC addresses. An IPv6 device uses ICMP version 6 neighbor discovery to determine the destination MAC address of a local device when it knows its IPv6 address. So if you have any doubts about this lecture, anything that we discuss in this lecture, you can pause this video right here. And this is a really good summary of what you should have learned for your quizzes and exam in this particular module. And that is the end of this lecture. If you have any questions or concerns related to any of the topics that we covered today, you are feel free to leave a message in the comments and I will make sure to get back to you. If you would like to watch the previous videos, as I mentioned before, I will leave a link in the description for the playlist of Cisco NetAcad Introduction to Networks lecture series. Please make sure to thumbs up this video as well as subscribe to my channel so that you would not miss my future lectures on Cisco NetAcad related materials as well as other technical materials that I'll be posting on my channel. Until next time, good luck with your exams and have a nice day.